My name is Insop. So today we'd like to go over agentic AI, agentic language model as a progression of language model usage. So here is the outline of today's talk. We'll go over the overview of language model and how we use, and then the common limitations, and then some of the method that improves towards this common limitation. And then we'll transition into what is the agentic language model and its design patterns. So language model is a machine learning model that predicts the next coming word given the input text. As in this example, if the input is the students open there, then language model can predict what's the most likely words coming next as a next word. So if the language model is trained with a large corpus, it is generating the probability of next coming word. In this example, as you could see, books and laptops have a higher probability than other words in the vocabulary. So the completion of this whole sentence could be the students open their books. And then if you want to keep generating the what's coming next, then we can turn them in as an input and then put it into the language model, and then language model continuously generating the next coming word. Then how these language models are trained, largely two parts, pre-training part and then post-training part. And then first, pre-training portion is the one that language models are trained with large corpus, text collected from internet or books or different type of text, publicly available text, and then trained with the next token or next word prediction objectives. So once the models is finished in this pre-training stage, models are fairly good at predicting any words coming next as a word, given the inputs. However, the pre-trained model itself is not easy to use. So hence the post-training steps are coming, and then these post-training stage would include instruction following training as well as the reinforcement learning with human feedback. And what this training stage means is we could prepare a data set such a way that specific instruction or question, and then the answers or the generated output, that is what the user would expect, or more related to the questions and answers. So that's how the models are trained, so that it's easier to use, and then also it'll respond to specific styles. And then once this done, and then additional training method is aligning to human preference by using reinforcement learning with human feedback, which is using human preference to align the model by using rewards schemes. And let's take a really quick look on the instruction data set. This is the template that we would use to train the model in instruction following training phase. As you can see, there's a specific instructions will be substituted in, and then expected output will be substituted in. And then this is fed to the model, and the model is only trained on the response part, that is generating the output based on the given instructions. All right, so language model that is trained on pre-training stage and so as well as post-training stage is quite capable of generating text given instruction. Essentially, it has a lot of world knowledge that could easily generating the outputs. So these are rapidly developing, and then these models are used in various application domains that we and we use day-to-day work, such as AI coding assistants or domain-specific AI copilots, or most widely known ChatGPT and related conversational interfaces. And then in order to use these type of models as for your applications or specific tools, you could use the cloud-based API calls towards the model provider or the model servers, or some other ways that you could also host the models on your local machines or even mobile machines for the models that are small enough or to host on these compute constrained environments. So what does it mean by using API calls? So we step back. The language model is taking the input, natural language input text, and then generating the output. So that means we need to prepare a certain form of free-form text, natural language text, as an instruction or a question, and then put them in a specific format that you could make an API call towards the model provider. And then the model provider takes that usually on a cloud environment and then generate the output, and then respond to your API calls with the generated output. Then your software around that, software that based on this model will parse the output and then use it as is, or maybe you could make a follow-up LLM API calls to further generate the output. So the input to the model is, again, free-form text. So how you prepare your input, also known as a prompting, is critical. So there are well-known best practices strategy, how you prepare your prompt. And here are some of them, and such as write a clear and very descriptive and detailed instructions that'll help the model to generate the output that you want. And you could include a couple of examples, the form that you want to see, as in the style or form. And also you could provide the references or context such a way that model rely on that context that you provide. And instead of just ask the model to answer right away, you could ask give model to time to think about it, such as reasoning, enable reasoning, or using chain of thought or COT method. And the next one is instead of asking model really complex tasks, you could break them down and then ask them chain in sequence. Also chain the complex prompts. And the last one is something that as a good engineering practice, have a good way of systemic trace and logging will help you. And also automated evaluation is always helpful to essential to develop your progress on your application. So let's take a quick look at on each items, what that means to get more familiar with. So write clear and descriptive instruction. As an example on the left, instead of asking short request, you could describe in detail so that model knows what you are asking, because model doesn't understand. Model cannot read your mind. So that means you need to describe what you want the model to generate the output for you. So this is always useful for using language model in general. And include few short examples. So meaning that give model the example input and output that you would expect. As in this case, you ask some type of consistent style output, then what is the consistent style? You provide an input as example input and example output that you ask, and then you can finally you ask your original questions. Then it's gonna be the model will generate the output based on your input. So few shot examples is always helpful to generate the output that you want to generate. So provide relevant context and references. This is really helpful for many of the cases that are related to generating text based on some factual information. So LLM can easily generate some incorrect output, also known as a hallucination, for those topics that it doesn't know or is not too confident about. So for those type of cases, providing context or references would always helpful. So here is the example prompt template that you would want to use in cases such as a retrieval augmented generation that we'll look at in the following slides, saying that only answer based on the input, based on the article that you provide. You could substitute your related reference and then only answer based on these references. If the model cannot find the answer, you could just say that cannot find the answer. Then model will likely generate the answer based on your references. So this is important part that give models time to think. In other words, instead of ask direct question, you ask model to think through it or come up with its own solution, and then finally generate the compare and generate the output. So this is also known as a chain of thought. So here is one example that might not work in some medium-sized model. You could ask model saying that evaluate the student's solution is correct or not, and then provide a solution description, and then finally give a student solution. And since the system prompt or your original request is saying that just answer it is correct or wrong, model might not get it right. However, for the same model that might not get the right answer for this, if you prepare your prompt in a way that you could ask first, work out your own solution to the problem first, and then compare your solution to the student's solution. Then by doing this, model will generate its own solution. And then as it does, it'll have an opportunity to provide good attentions to all these inputs that it's from the original input as well as the output that it generated, and then turn towards the right answers. So reasoning chain of thought is always helpful to generate the output that you want to see. So here's an interesting one, probably easy to implement for your application. So instead of asking your request that includes, say, multiple tasks in one request, you could prepare your prompt in small, simple stages. So how you do is prepare a simple prompt and then generate the output, and then prepend the output to the next stage 2 prompt, and then generate the output, and then again prepend the output from the previous stage, and then generate the output in a third stage, like here, and then finally generate the output that you'd want to see. So by doing this, you may need to do it manually, or this can be done by LLM, as we'll see in the following slides. But having a simple, clear task per each request would be a good way to do it. Okay, so this may not be obvious, but because many type of as with many engineering application or development, having a good way of keeping, tracing, logging will definitely helpful for your development, for debugging, as well as auditing. So same principle applies to language model-based development. So keep track of the log is always good. And so that also relates to having a automated evaluation from the early stage of your development will definitely help you. In other words, you need to prepare a question and answer pair, ground truth answer pair, so that you could compare that against the generated output. And you could use a human to evaluate that, but that's usually costly and then time consuming. So you may use a language model as a judge, meaning that you could ask language model to evaluate model generated output as well with ground truth output, so that model can score the generated output's quality, so that you can use that against your currently developed your own applications. This will help. This will be very important because the language models are continuously and rapidly improving, as well as the methodology and then tools that you are using for developing language model is also rapidly developing. In other words, without clear evaluation, it is hard to make forward progress, or even hard to change the model, change the different type of models, because the models are rapidly developing. Also means that some models are rapidly deprecated, which means you may need to force to change your language model that you are using in your application. So having good evaluation methodology upfront from the beginning will definitely help. All right, so this is a simple idea, but will be helpful for many applications. So instead of taking your input prompt as is and then process it, you may have some software or some model that you could detect the intention and then send it to a different prompt handlers. So, or this is also known as the prompt router. So based on the input query type, you may need to use simple prompt together with simple language model. And then this will both help in terms of operation costs, as well as generate more appropriate output together with more relevant prompt with the language model that is more capable of that type of query. All right, so maybe Petra, if there, this may be a good moment that we could take question if there's any, if you could see.
Yeah. Thank you so much, Insop, and such an inspirational talk already. Thank you so much. We will get to more details about agentic AI just shortly. We did want to kind of provide you with some sort of a background and kind of the progression of what has been going on in the field. But I think maybe let's ask one question that came up. It's a little bit specific, but it might be what more people are wondering about. And is there any optimal amount of data to perform a good training, or anything that you could advise people around kind of the data available, or data being used?
Okay, maybe I'll be short on this. So I assume the training here is meaning that fine-tuning the LLM as part of additional training on top of open source language model. Yeah, depends on your task. It would definitely vary, because it's hard to say one or the other. But if you if you have your enough data set or text that you would want to see, then you may come up with a simple question and answer pair or instruction following data set format. And then you could also make use of language model to further generate more. So if you needed more, but I would think you would start with say tens of data samples of data set first, and then see whether that makes the model behave what you actually see it to be behave, and then you could add based on the result or signals from the initial quick test, then you could additionally add more data set samples, possibly use the language model to augment it or synthetic data that you could create. Great question.
Thank you so much. I see like questions started coming in, which is wonderful. I think we will pause the question for now, and we will try to get to as many as we can at the end, but please keep them coming. It definitely makes the session kind of more engaging, and also let us know what you are interested in. Thank you.
Thank you, Petra. All right, so so far we've been looked at overview of language model, great, very powerful models that are out there, many models out there, and then how we use. However, even there are still limitations for models that are available that are listed here, such as hallucination is a well-known issue that models can sometimes or oftentimes generate incorrect information, particularly if it's related to some computation or some other specific area. So this is also this is a problem that is that we want to avoid in your application domain. And other thing is there's always a knowledge cutoff in dataset preparation. So model creator prepare dataset. However, they need to at some point cut up their dataset collection and then use it. So model may not know, may have not seen the recent information or news as part of their pre-training dataset. Lack of attribution. So model can answer a lot of world knowledge questions and can answer those type of general questions. However, it may not tell it. It's not going to tell you where they drew this the answer from particular specific data source. Data privacy is one fact that model creator prepare the data set using publicly available data source. That means model have not seen your proprietary data set from your organization or particular domain. And limited context length, although it's rapidly increasing, however, it always it's fine balance because providing longer context will give more context information to the model. However, it comes with operational cost as well as the speed, the latency in text generations. So in order to address these common limitations, retrieval augmented generation is one way to handle this, such as it could reduce the hallucination by using the actual relevant reference. It also addressed the citation because it knows where this reference is coming from, and then this will allow you as an application developer or a system developer to prepare systems so that you could use your own proprietary data set or the text, and then you could use the good use of a small number of context lengths because it only select relevant data set. So how it works is you could pre-index your own data set or your own text by turn them into smaller chunk of text, and then convert them into embedding space using embedding model, and then stage them as part of your database or vector database. And then when the request or query came, you could turn this query into embedding space, so that you could do a nearest neighboring search and then select top K relevant information, relevant text chunk, and then place them as part of your prompt. Some of the slide that we see previously as you put the reference as part of the prompt, and then use that as the model only make use of this reference. So this is one good way to make use of your own proprietary data. And then similar method is can be used in the actual AI search, or so that instead of using index data set, you could also rely on web search or different type of search, so that you could provide the information as part of the index. And one of the things also mentioned here is there are many methods or ideas for retrieval augmented generation. More commonly used method is something that we've just mentioned. We've just talked about, meaning that turn the text chunk into embedding space and then do a nearest neighboring search. However, there are many methods, and then you could also use knowledge graph base. So if you could generate a knowledge graph from your text source, and then that could also help to extract the more relevant information. Also known as a graph rag is one part of it. However, there's many methods, and then you may need to look into the right method, or if the right method, and make use of those. All right, tool usage. So language model being most widely used form is a text in and text output, which means that it could answer many type of queries. However, it's not gonna execute or extract information from the external. So that's where this tool usage came to rescue, or also known as a function calling. So with this method, you could get real-time information, or you could actually do a computation by generating software or computer code. So what does it mean is, let's look at an example here. So if you have an AI chatbot, that if you ask what is the weather in, say, San Francisco, then model will not know it in itself. So, however, if you tell model previously, if as part of the prompt, saying that if you're asked weather-related question, generate an output in a form that the software that parse the output can make an API call. So as in this example, model will generate the output in a way that, hey, this is the case for tool usage. So it generates an output as in the form here, get weather, and then input argument to this API call or function call is the place that we asked. So then software receives this text output from the model, and then parse, and then actually make an API call towards the weather provider, and then get the weather information, and then again provide back to the language model, and then language model will generate more human-friendly or helpful output based on this API-based result. And for some cases, a model can also generate a software code that can be executed as part of the sandbox outside of the language model by the software that is coordinating all these activities. All right, so agentic language model. So there can be many definitions one definition is it could interact with environment. So compared to simple language model usage, generally use simple language model usage as you see in here, text input and text output. Agentic language model usage could be language model could do something with environment by generating tool usage or retrieval request, and then from the environment, anything outside of language model could could provide an output, could provide an information that can be fed back to language model as an observation, and then the whole thing, the agentic language model, which includes language model at its core, with the software around it, will process it, and then also put them in a memory. And as with its conversational history, which can be taken as a memory. So this is one way of definition of agentic language model. The other way to look at it is this: agentic language model usage can be defined as it could reason as well as it could action. It could do an action, so also called react, reason, and action. So reasoning part is something that you could encourage model to reason about by using a method such as chain of thoughts, and then doing an action using a method that we have seen previous slides, as in retrieval or search engine, or actually using calculator by making an API call, or different type of API calls such as weather API that we have seen, and also generating a Python code so that you could run as part of your sandboxes. So by combining this reasoning and action, model can do a lot more complex tasks than simple input and output type of interaction. So here is, let's look at a little more detail on this. What does it mean by reasoning and action? So reasoning part, instead of doing the task that is asked, you could prepare your prompt such a way that ask model to break down the task and then make a plan. So instead of breaking down the task by yourself, as we see in the previous chaining the prompt slide, you could ask model to break down and then prepare your task. So in other words, plan the actions, and then based on that breaking down, model can generate different actions by making an API calls or tool usage, so that it could extract or collect additional information from the external world, and then by combining all this, put them in a memory so that it knows, model knows what's been happening, and then based on that, finally draw an answer for you. So let's look at the concrete example here. So if you have a customer support AI agent, then how it might work. So as a customer, ask, can I get a refund for product full? Then agentic system will break down this request task into the following 4 different type of actions. Check the refund policy, check the customer information, and then check the products, and then finally collect and then decide what to do. In each step, language model will spit out the API calls so that it could collect the information. For example, check the refund policy. Language model could ask a retrieval system against the pre-indexed company policy, refund policy, and from there it could retract the information and then put them in its own context. And then using that, also request a customer order information it could either ask customer back to in a chat format, collect more information, or you could look it up in the system, because depends on how this chat system is prepared. The same thing for the product, so that it could collect more information and then finally draw the conclusion based on the policy and then product information as well as the customer order information. And then send a request to the follow-up system as a API call, as well as the prepare say response draft, and then that's going to be handled by final approver. All right, so workflow is generally like this. So in a sense, agentic language model system is generally LLM is making language model is making iterative calls by reviewing the document or task and then making an external tool calls. Things that an example, if you want to do some research of certain matters, you could prepare your agent to do a research, web search or different type of search, and then keep summarize them, and then iteratively, and then finally prepare the report to you or to your system. Another example could be software assistant agent that you could ask this software agent or SUI agent that ask the issues of certain type of software bug or issues. Then this agent will look it up and review this issue, and then collect the relevant piece of code or files, and then review them, and then propose the output, or it could also execute in its sandbox environment, and then test the fix, and then get the output, and then iteratively try to find the fix, and then finally propose the pull request or the changes to users or developers. These are the ways that we can use language model in agentic format, and by doing iterative language model calls. So the difference, main reasons and difference why this agentic language model usage is getting more widely used is given that if you have the same model, if you ask just direct request to the model may not be able to handle it. However, if you put your task in this type of agentic format or patterns, then model will do more complex tasks, even using a model that may not be able to do it if you don't do this way. So that's one of the reasons that agentic language model is pushing the boundaries, so that the things that we can do with AI agent is more complex or different domains that we can rely on. All right, so here are the real world applications: software development, code generation, or bug fixing, or this type of development is widely investigated or being researched by different organizations, as well as there are companies that trying to provide these services, as listed on the right side, and research and analysis that gather information, synthesize it, and then provide a summary for the users. And then task automation is one of the area that agentic method could be used. All right, so to make it more clear, here are some of the design patterns that you could use. Use agentic language model. Planning is critical, because by asking a model to break down the task to make it simpler task or clear task, so that the language model later can make an API call or use the tool usage. So planning is critical. And then reflection is something that model can generate in itself. And then the next model call can criticize the output that actually came from the same model. So by doing this, the output could be improved. And then tool usage is something that something that outside of the language model that you need real-time information or different type of information, then you can use this. And then multi-agent collaboration is one way to handle this. Reflection is a pattern that's quick to implement and then leads to good performance. And let's use a concrete example here. So if you want to refactor a programming code, instead of ask the model to improve it right away, if you do this pattern, as in this example, saying that you ask a model saying that here's the code, and then check the code and provide constructive feedback. And then take that feedback to the second prompt, as in this example. You could also prepare prompt saying that here's the code and the feedback which came from the model itself, and then ask the model to refactor it. And then this way of reflection will likely generate better output or better fix for the code that you are asking to the model. Tool usage is something that we've seen it before. Ask model to generate the API patterns so that you can use this API function prototype to make an actual code. Or if the task is related to actual computation or some different form, you could also ask model to generate a program as an output, and then you can run that on a safe sandbox environment that your software or software scaffolding around the language model can execute, and then provide an input, provide the execution output back to the model so that model can synthesize it. All right, so multi-agent is an interesting way to implement or accomplish your complex task. So you could split up the task or you could split up your task and then assign those tasks in a different agent that are dedicated for specific tasks. And then this agent is, in this case, in this context, could be just as a different prompt or different persona. So you could, the prompt usually consists of you are an helpful AI agent. You could change that into a different persona to a different agent. And also you may or may not use the same model or the different models based on the task. So let's use a concrete example here. So if you build a multi-agent system for smart home automation, you could create a different agent, a climate control agent, lighting control agent, and so on. And then these are the software piece that includes a different prompt with a persona, as well as handling external triggers. And then those are the ones that work internally, and then that coordinate these agents, essentially a model prompt together with software scaffolding around it, coordinate the whole activity. All right, so that brings up to our summary. So the agentic language model usage is a progression or extension to a existing language model usage method. So for the best practice that you have used in language model, simple cases, most of them are applicable. However, you could use different additional methods such as more retrieval, search, tool usage, and then prepare different type of prompts, and then workflow so that you could use language model as its in its core as a reasoning or smart intern. And then you could use a tool usage or other retrieval method to interact with the external world, and then combine these results, and then such a way that you could achieve a complex task instead of simple input and output type of language model usage. And that said, Petra.
Thank you so much, Insop. This has been really great. So much information. Hopefully this is useful for everybody. We keep collecting the questions. We got so many. We will try to get as many as we can. But yeah, please feel free to keep them coming. Maybe the first question for you, Insop, and let's focus on the agentic AI, is about the evaluation. And do you have some recommendations for a good strategy for evaluating agents beyond just using an LLM as a judge? It seems it should be a little bit more complicated to do the evaluation on agents. At least that's kind of the general notion, the questions, and people are wondering how that could be done.
Right. I think this is a great question. Just to make a quick context, LLM as a judge is commonly used method that you actually use LLM to evaluate the model-generated output against the ground truth answer or some type of reference information, which works great and then widely used. And also we use that as well. For the, I think one thing that I've recently tried is agentic judging method, meaning that I use reflection type of pattern that we have seen previously. Instead of just ask one question right away to LLM as a judge, I ask first LLM as provide initial reference and then feedback, and then I also ask again another LLM call or different prompt saying that, hey, this is a feedback from your junior engineer. If you are a senior engineer, how would you compare the junior engineer's evaluation against the output that you are evaluating? So I find that this reflection pattern was helpful to get the better evaluation instead of just one-shot LLM as a judge output. However, I think there can be a more creative way to improve your evaluation stage using agent patterns, because the evaluation, it is really, really important. I can't emphasize more, because that will help you to advance fast or change models and different type of changing the prompt and so on and so forth. So I think that was a great question.
Thank you so much, Insop. We got a few questions about kind of augmenting the AI agents for specific uses and making sure that kind of they get shaped in a way you need for your application. Like on the technological side, like what is there to do, what is there to use? We got many questions kind of like going to this idea. So if you have some kind of information, it would be helpful.
Right. Again, I think this is a great question. First thing came up to my mind is, if you have a task which is simple already, then you just use language model simple use cases. However, if you see a little more involved or complex task, you could experiment with a simple agentic task, even if it's agentic language model usage. You can define agentic language model in many, many different ways. But if you have a little more involved task, you could do iterative language model call. Even that could improve your output. So I think it all depends on your test case, actual application domain. But instead of trying to look for the task that you could apply language model, turn that around, that how this task cannot be solved with the simple cases. So simple language model usage. So try to apply simple usage first, and then try to improve it using different patterns. Same for, I think, a slightly tangential, but fine-tuning cases also. If you could have a task, if you have a task that you want to solve, try to use the existing model first and whether it makes sense or not, and then from there you could decide how to do it. Then you could prepare small data samples and then try it, and then make a progress, and then a really quick iteration instead of trying to invest upfront too much.
Thank you, Insop. A few questions came in, and I will this is like a kind of giant question on its own, so I will kind of let you choose how you want to respond to that. But a lot of questions about kind of ethical considerations, how to avoid hallucinations, like how to avoid kind of like using data that might be like unethical, or like there might be something kind of behind them. What would be your recommendation? Again, like this question is so big, but maybe like looking for something that you would say about this.
All right. Yeah. Another great question. Yes, due to its probabilistic generation in nature, hallucination is always there, although a lot of people are working on it. So it's a problem, as well as the contents output has a concern, could be concerning. So I think a model provider themselves is checking the generated output in terms of different categories, as well as your application application builder yourself also add some guardrails. Guardrails being checking the output using small language model, so that you could quickly check the output, or some type of I guess a criteria using classifier or some type of thing, so that you could actually filter them out to see. It could be either on the final generation stage, or it could be in taking in the input stage that the query comes in, so that you could actually avoid it. This can be can backfire, but I think as a enterprise or business, you may be on the safer side, so they're making sure generated output, as well as the inputs queries that being requested could be more safe or reasonable cases. So this is evolving, but I think fundamentally it is something that check the output using type of classifier or even decoder type model to check it.
Thank you so much. And a little plugin, we do have generative AI program that also covers a lot of kind of the ethical aspects of kind of LLMs. It's not a technical program, but like I'm kind of reaching to people who are asking about this sort of very important questions. Maybe last question, Insop, for you. And, you know, we are not going to be endorsing, of course, like at Stanford, but like a question is like, how to get started? Are there any open source models to recommend? Is there anything kind of people can do to kind of start testing this out, like start playing with this?
Great question. So one thing that as a take-home message here is start simple, and then experiment it, and then iterate it. So that's, and also agentic language model sounds complex, fancy, but it is a progression and extension of language model usage. So to start, I think you could, there are many language model usage framework and also agentic framework that you could use. However, to start, I would suggest to use playground type of environment. Say model provider generally have their playground that you could type your prompt or input, so that you can see the output right away, so that you can experiment it really quickly, and then once you get familiar with it, and then use the API to make a call from your program, and then see what's going on. In that way, you gain insights as well as practice best practice for prompt preparing. So once you have that, you could intelligently decide whether it makes sense for you to actually continue your own code base or make use of widely available libraries. So in short, start simple, work on a playground first, and then make a simple API calls, and then decide whether you want to use more extended libraries or just continue your own way. This applies for language model usage as well as agentic language model usage as well, because there's also many agentic language model framework out there.
Thank you so much. And to close us out, like in this session, in the last minute, Insop, the field is progressing so fast. There is so much happening. Basically, every week we see news about something new coming up in any of these fields. Are there any resources you study, you follow, anything you would recommend people to kind of keep track of to stay up to date in LLMs, agentic AI in this field?
Difficult question, but great question. I think it's a little hard, but I picked some experts who are known in this field. I follow them either in formally Twitter or YouTube channel, and then from there I get more updated information and then do my own diggings. But I think find out the good starting point is a good thing, and then I think a reference here. You can screenshot it, and this can be a good starting point because it includes some agentic usage courses as well as a good type of courses, either from Stanford as well as different places. So yeah.
Thank you so much, Insop. This has been really great. So much helpful information, and you're absolutely the best person to hear this from. Thank you so much for taking the time. Thank you also everyone who joined us live. Thank you for your time.